So, I want us to motivate us about learning these trig extensions, right? Before you ask me what they are, as an example, right? When you've got things in here, okay, different angles or different functions, that kind of thing. So far, with trig, we've learned that you can't really muck around with that. You can't just say, for instance, you can't just divide through by n and get 6 or something like that, okay? So we have had trouble working with, remember this is called, this inside thing, no, sorry, I've told you 12. This inside thing is called the argument, okay? So you can't really sort of take it out or factorize it, that kind of thing. It's not straightforward, okay? For instance, this is definitely not just this, okay? If only life was so simple, okay? So, we're going to have a look at these, right? But I want to try and get you along the way to y. Okay? So the first thing to think about is exact values. Exact values. Now, for your trig functions, sine, cosine, tan, okay? You learn a set of exact values for different angles, right? What are the angles you learn it for? Okay, we actually start with 0, okay? And then the first one is 30. And then before 60 is 45, okay? Then 60, and then 90, okay? 5 values, okay? Now, there's a few different ways to remember what the exact values are, okay? So I'm going to teach you number 1, the one I learned when I was in year 11, and number 2, one I learned years later, which would have been useful to me in year 11, but I didn't get to it until I was actually at university, so maybe it'll be useful too. What's the first way, okay? Draw up 2 triangles. Draw up 2 triangles. And maybe you're familiar with this one. One of them should be isosceles. They should both be right angles. Okay? So you've got a skinny one and a somewhat less skinny one. Okay? What do you do with these? Okay? They're both right angled, yeah? So in these 2 triangles, I can put all of these angles in and then get some of the sides out of them through Pythagoras. Okay? So this one here, the thinner one, okay, because the angles are different, we call this small one 30 and the other one 60, because it's supplementary, okay? Now, what's required in here is that you have to remember one ratio, the first one, okay? The easiest one most people tend to find is sine 30. Sine 30, which is equal to a half, because it's a simple fraction. It's the one without square roots, okay? And you remember by this point, I think you've been hammered into your head enough, that sine is opposite on hypotenuse, right? So there's 30, opposite on hypotenuse, okay? And it takes pretty short space of time to work out what the third side is, which is root 3. Okay, with that triangle, you can work out sine, cos, tan for 30 or 60, okay? Any of the different combinations, okay? Example, tan 60, tan 60. Tan's opposite over adjacent, right? Sokotoa. So tan 60 is root 3 on 1. Root 3. Happy? Okay. You can rinse and repeat for any kind of ratio you like with 30 or 60. This one, of course, is the other one, 45. And that's why I told you it had to be isosceles. Because equal angles equal sides, right? Okay, now, if I've got equal sides here and I make those both equal 1, right? Then my hypotenuse will be root 2. Okay, and so from here you can get sine 45 and cos 45, right? They're both equal to 1 over root 2, and of course you can get tan 45, which is 1. Okay. All right. By the way, don't forget sine and cosine, right? For instance, sine, I already wrote down sine 30 is equal to a half. You can see if I went from 60 and did say cos 60, okay? So that's going to be adjacent on hypotenuse. So cos 60 is equal to a half. And I could reverse it as well. Sine 30 and cos 60 would be equal. Cos 60 and sine 30 would be equal, okay? Because that comes back to what cosine stands for, right? It's an abbreviation. It stands for complement sine, okay? You guys know what a complement is, right? As opposed to a complement, as in you have, that's a nice haircut, right? A complement in maths means adds to 90, right? So if you got these two adding to 90, then you'll have the same ratio. Okay, they are the same ratio. Okay, this is the way I learned, right? So more or less at the start of every senior maths exam, the first thing I do after reading time is over is I just draw these 2 triangles, okay? But I learned another way. So, I want you to take your hand and put it down on your page, and then draw an outline around it. Okay? So it should look like this. Don't my fingers look that fat to you? That looks pretty realistic to me. Okay. Okay. Now, what I want you to put on here, okay, is on the palm. I want you to write this. Some of this will be very mysterious at first, but it'll work out. Okay, I want you to put the square root of x onto. Okay. Then on the fingers, right? 5 fingers on each hand. I want you to put the 5 angles. Okay. So over here, I've got 0, 30, 45. Who's seen this before, by the way? Who's seen this? Really? None of you? Okay. Well, I suppose that's what happened to me. Just wait till you get to show people this in your grade, and their minds will explode. Okay. So here you go. You got that drawn in. Okay. Now this is my left hand at the moment. Okay. Because my little finger. Anyway, yeah. This is my left hand. All right. I suppose I'm looking at it this way, okay? So I want you to, whichever hand you've drawn, maybe it'll help you, you've got the same one as me, okay? I want you to hold it up the same way your page is written, okay? I forgot one more thing. On here, I want you to draw 2 arrows, one coming from the right and one coming from the left. The left one should say sine, and the right one should say cos. Okay? Alright, now, here we go. If I want to work out the sine or cosine of any of these exact values, here's what you do. You take your hand and you say, well, which angle do you want? Which angle do you want? Well, let's do 30, because we already know what the results for 30 are, right? Okay, I'll take 30. 30 is my index finger, so I want you to put your index finger down. Can you do that? Can you manage? Okay? So now what have you got? What have we got? Okay? On the right-hand side, I've got 1 finger. 1 finger? Okay? So that means that sine 30 is the square root of 1 finger on 2. Square root of 1 is 1. Sine 30 is a half. Is that okay? You see that? Okay. On the right-hand side, I want cos 30. I've got 3 fingers over here. Okay. So cos 30 is root 3 on 2. Root 3 on 2. You see it? Okay. All right. So that was 30 degrees. Let me give you another one just to try. Okay. Let's do 0. Okay. This way is better because you can do this with 0 and 90, which you can't do with the triangles. Okay. I put down my thumb for 0, okay? So what's sine of 0? Well, I have no fingers on the left of the finger I put down, right? So sine 0 is 0 on 2, which is 0, okay? But cos of 0 is, how many fingers have I got to the right? Of course, I got 4, right? So cos of 0 is 1, 2, 3, 4. Root 4, which is 2, right? On 2. Cos of 0 is 1. Let's do one more, okay? Rock on! Okay, so I want to do 45 degrees, okay? 45 degrees. Sine of 45, what is it? It's root 2 on 2. Root 2 on 2. Root 2 on 2. That's 1 on root 2, isn't it? I just took out a factor of root 2. And of course, because I got the same number of fingers on both sides, sine 45, and cos 45 are the same. Does that make sense? And I could keep going if you want, but my fingers are cramping, so I'm going to stop. Okay. So, there you go. That's kind of handy. You don't need to draw triangles. Yeah, get it. It's handy. Yeah. I seriously didn't. And I think actually what's better about it is that 0 and 90 work. Okay, because you can't do that from 60s. Now, what's my point? Why did I use that as an in for looking at trig expansions? Okay. Here's my first reason. I'm going to give you another one as well. Okay. My first reason is, if you just got these exact values, okay, I can't really deal much with anything that's outside of those values, even if they're nice, neat combinations of those. Things which I know ought to have an exact value, right? Or things like cos of, say, 15, right? Or any other combination, okay? If I take 30 plus 45, or 45 minus 30, okay? Because these aren't those 5 values, you're just stuck. Get your calculator out. Good luck, go home, okay? But with trig expansions, if I can actually write this as something meaningful, okay? Turn it into something I can actually work with in exact terms, I won't be stuck with a decimal anymore, okay? I can actually get something exact. This is my first reason. You can actually expand what you can do with your exact values. Okay? And secondly, which unfortunately I don't have heaps of time to go into, but actually in real life, the trig functions that govern real life, so things like acoustics, which is like sound, okay, communications, which is electrical signals, anything which oscillates and waves around, okay, they all have lots and lots of things in there. Things aren't just nice and neat. You've got one thing in there, and okay, work out your value, okay. You've got lots and lots of values in there, lots of variables, lots of actual functions. Sine of cos of this, right? So it's very complex. I need some way to break it apart, okay? So that's what trig extensions is about, okay? Right.